Hey everybody, I hosted the local metalworkers group yesterday, and so I cleaned up the shop, and it's a good opportunity to show you guys my setup, and I hope you like it. So over here we have the inspection area. This is an optical comparator, and then underneath there is the precision granite plate, and you have indicators to set up your tooling or confirm um, your cuts and your parts that you made are to size. And then all in here is inspection and measuring tools. And I won't get into the depth of everything. This will be the overview. And then over here is setup tooling. And in these drawers are common use tools like taps, drills, end mills, hardware, and for checking threads and stuff like that. Over here is the material section. Built it like a honeycomb so that it'll accommodate long material, small material, and in the back full sheets. It's everything's a little squeezed in here. Then the box up here is all the hardware, nuts, bolts, casters, bearings, anything to assemble things or set up the shop. Up there is all the surplus equipment, materials, cutters, everything to support the shop. All these machines each have dozens to hundreds of accessories to get their full capability. Down here we have a MIG welder, and then tucked in the back is the plasma cutter, 7x12 horizontal saw for cutting raw stock. That corner there with the grinders, that's not really set up yet. It was set up differently before, and then I changed it. So they're just setting there, and so haven't been using those much lately. Tucked up there is my air compressor, which I did put up there all by myself by hand. Then this here is a surface grinder, and that's for grinding precision surfaces. When you grind, you make quite a bit of sparks, and then the grit that comes off the grinder is very damaging to the other equipment. So I try to capture as much as I can through this ductwork. And right there is a spark arrestor. And normally they're very expensive, but that's from a diesel tractor trailer. So that knocks down any sparks that might get that far. Usually they don't. But then it goes through a cyclone, which drops out the heavy materials because you don't want the grit to get all the way inside the filter system, because it'll damage the vanes of the pump. Then over here is a 1942 K.O. Lee tool and cutter grinder, which is used for making all sorts of tooling for different cuts that you would make. Nowadays, you can buy a lot of this stuff pre-made, or tools that use carbide inserts. So right now I have it configured as a cutoff tool, which is very convenient. So if you have just bolts that you need to cut to length or small raw stock, you just chop it instead of getting into anything more elaborate. Over here is a welding table setup. I had a much bigger one, but with some other additions in the shop, I had to downsize. So right now this is a convenient size for me. I did a quick setup to show some of the accessories that go on it. So you have a square, and then you're able to constrain all the material. So one, you'll hold it in place, and two, it won't move during the welding process, so it won't warp on you. So you can constrain it this direction, constrain the material so it stays square to the square, and then this constrains it this direction, and then it's all clamped together. This is one of my nemesis. This is from a machine you'll see in a moment that's all apart. Up there is a phase converter. Residential electricity is only single phase, but most machines run on 3-phase, so this converts it. Good way to think of phase is like a merry-go-round. Think of one person pushing the merry-go-round or 3 people pushing the merry-go-round. So every revolution, a single person just hit it once, but if you got 3 people, so that the electricity is more constant. It's not on, off. It's on. Okay, so over here is kind of a catch-all, but here is the ultrasonic cleaner, so that uses heat and vibration to work loose any grime or grit that's in parts, and I've been using that a lot because I'm rebuilding 2 of the machines. And that jug is a setup with 30% acid vinegar, which works for stripping scale off of steel or rust, and it's safe to use. Some of the acids are tough on equipment or your skin or health. This I call my MVP. It's a pallet stacker, and it's lifted many things in here that I couldn't do by myself. And then right next to it, behind it, is a crane addition I made that bolts onto that, which makes it possible to pick stuff up like that. So this has turned out to be my pride and joy. This is the first year, 1950, Hardinge HLV lathe, the first precision lathe in the industry. It would go on to evolve into a little bigger platform that became extremely popular, but is also still very expensive even when they're 30 years old. Then this other lathe here is a bigger lathe, and I got this out of California. My buddy Lawrence and I went and grabbed it in the middle of winter with no heater in my truck, so it was 30 degrees going across the desert, which unfortunately kind of sucked, but he was a trooper. And so I got a good deal on it, but it needs some work, so it's half apart. This is one of the things I'm dealing with. This is supposed to be pretty like that. This distributes oil to the carriage here, and you can see all the lines had broken out. So I think I know a machinist that can make one of these if he ever gets around to it. Over here was the first machine that I ever got, and this is a mill, and it can be used manually or with the computer as a CNC, so it's extremely helpful for making intricate shapes and repetitive tasks, bolt patterns, stuff like that. And it had gotten an oil leak, and just like with anything, once you open it up to address one issue, you find other issues. One of the things that's cool that it can do, and I'd like to do some as soon as it's going again, is things like this. You know, once you program it, you can make hundreds or thousands of them all, one after another. It's dirty because I use it just to collect chips. So over here is my mechanical toolbox. Over here is a bunch of the accessories that go with the mill. Sorry for some of the lighting, I didn't plan ahead for that, but so there's tons of accessories, and so this shelving evolved as I added stuff. I had to keep going up and up, but it's a heavy-duty shelving, and there's actually a steel exoskeleton that's around the mill that supports all this. So you can see the beam there. There's one snuck along the wall there, and then it goes into the corner, and but that makes it so it can handle the weight, because I can't attach to the floor because there's cable tension that runs in the concrete, post-tension concrete. This is my first machinist toolbox that I used when I worked for a short time in a tool and die shop. And as you can see, I have as many of the right tools as I can get. So this is high-end, larger drills, and there's actually even bigger up there. Just makes life easier. You can hog out your holes ahead of time, and then you would follow up by like doing boring operations with like that. I skipped right past my mill. This is a 1971 Bridgeport mill. But then, as the business end, which is the head, was getting kind of worn out, I went ahead and put a brand new Taiwanese one on, which is all electronic, high speed, more power, and was just a lot better, especially since I already had 2 other machines taken apart. It was a better option to just switch it out. You might have gotten glimpses of this. So this is me making everything into a project, but since I can't go into the floor with anything, this is a beam that's super heavy duty, and then it ties into the wall, which is tucked away back there into a couple studs there. Then it's tied into a couple studs back there, and then another one over here. And then I tied it into the base of the Bridgeport, so there's another 2,000 pounds of ballast, and that is the shop crane. So as you can see, I made that. Some of the welds aren't pretty. I want to go over them again, but so far so good. It's held 700 pounds all the way at the end, but with the dog leash, I can spin it around. I have to just move the crane out of the way, but it rolls around. But I can spin that around about 50% of the shop, most of the areas I need it. So I'll take a moment to fire them up for you. So the phase converter, what's nice about that is everything's daisy chained. So when that's off, oops, I'm not even looking at it. So when that's off, there's no power to any of these machines, which makes it so I can sleep better. You know, because this is all old electronics. This machine is 73 years old now. And that's all old school. The wiring gets brittle. Okay, so we'll fire that up. And everything's fairly quiet because I live in a tight residential area. I only have 5 feet of easement on each side of the house. Also, I'll sneak over here real quick. It's air conditioned. I'm in Phoenix, Arizona. So it's beautiful in here. It's 70 degrees. It's good for the machines. Keeps the moisture off of them. Keeps, with almost everything all steel, they absorb the cold. So when it does get hot, they work as a buffer during the heat of the day. And then there's a TV there, of course. Got to have that. So there's the phase converter. So we'll go over to the mill. So, so I don't even know if you'll hear it, but the original heads would be very loud, even when they're in decent shape. And the one I had was getting old, but it's a high speed. I think the max speed is 4,000 RPM on it. But it turned out to be a lifesaver. With the other mill down, this one has done a ton of work. It's really worked out well. The table, even though it's pretty worn, it seems to be worn evenly. So that's good. It holds really good tolerances. It's tight. It stays put. Some of them, when they're in bad shape and you're trying to cut, the table will shift around on you. Then the hard hinge. This again is going to be quiet and smooth, like the Bridgeport, but these were always quiet and smooth. They're known for that. So there's a power feed. make it out, but it's feeding all by itself. I won't do a cut because I got to pay attention if I'm doing a real cut. So, but then the grinder is a little more violent. We'll fire it up, but we won't do any cutting with that because it's not really set up. I just displayed it. This contraption below is a compound sine, which makes it so you can tilt in 2 axes, so you can compensate for material that's tapered. So I don't know if you can make that out, but the end to my left is thinner than the end to my right. But when I need to resurface it by grinding it, it has to be level. So using trig, you figure out the angle and then you set up with blocks. They're snuck in there, and that's tilting this whole stack up. So I guess that's it for now. I'll dive into the rest of it a little more in depth maybe, if this goes over okay. Thanks a lot. See you later.